What if the particles driving your next yield excursion are the ones your current metrology never sees? At advanced semiconductor nodes, CMP performance is controlled by detail at the nanoscale. And when multimodal particle populations, precursors, and sub-10 nanometer contaminants go undetected, scratches, instability, and yield loss follow. For process engineers, yield engineers, and CMP slurry suppliers, these are problems you can't afford to miss. CMP slurries have become more complex, but traditional measurement methods haven't kept pace. Dynamic light scattering and conventional optical techniques often reduce complex slurry behavior into a single broad signal. The result? Hidden particle populations, poorly resolved multimodal distributions, limited visibility into dissolved non-volatile residue and precursor behavior. For process engineers, that means incomplete understanding of how slurry PSD affects polishing rate and stability. For yield engineers, it means defect sources remain buried until they become expensive. For slurry manufacturers, proving consistency and performance becomes increasingly difficult. The problem isn't the slurry. It's the measurement. Optical and centrifugal methods introduce ambiguity at the nanoscale and struggle to detect the sub-10 nanometer particles and precursors increasingly relevant at advanced nodes. When critical dimensions are below 5 nanometers, you need more than estimated distributions. You need real particle insight, because you can't optimize what you can't resolve. This is where the Kanomax FMT Liquid Nanoparticle Sizer changes the conversation. Instead of relying on optical interpretation, the LNS directly measures particle size distribution using engineered nebulization, evaporation, electrical mobility classification, and condensation particle counting. The result? High-resolution PSD measurement from approximately 6 nanometers and above, with fast, process-relevant insight. The LNS doesn't just measure particles. It reveals what conventional methods miss. Process engineers gain clearer visibility into multimodal slurry behavior, faster formulation optimization, stronger control over polishing performance. Yield engineers gain deeper insight into defect-driving particle populations, improved root cause investigation, earlier detection of process excursions before they impact wafers. With up to 64 channels per decade of resolution, the LNS quantifies populations that previously remained hidden. And because the system reports absolute concentration, not normalized percentile data, the results become directly actionable. In comparative studies involving SEM, DLS, and LNS, the difference becomes difficult to ignore. The same silica slurry, different story. While DLS interpreted the slurry as largely unimodal, the LNS clearly resolved the multimodal distribution. When comparing batches, LNS revealed similarities and differences that traditional methods struggled to capture accurately. This isn't just better measurement. It's better process understanding. For CMP slurry manufacturers, tight PSD control has become more than a quality target. It's a competitive differentiator. The LNS enables faster formulation development, traceable quality control, stronger batch-to-process alignment. Because when you can directly correlate PSD to fab performance and defectivity, you create stronger validation, faster troubleshooting, and greater customer confidence. Advanced nodes demand deeper particle insight. The Kanomax FMT LNS Model 9310 gives semiconductor engineers and slurry suppliers the clarity needed to better understand, optimize, and control CMP slurry performance. Stop relying on incomplete data. Start seeing the particles driving your process.